Tower will go at about 15 seconds away from launch. We're at 24 and counting now. The ground umbilical to the third stage has been disconnected.
Auto sequence initial.
Second umbilical tower now separating. Boosters igniting, the engines firing. Ramping up to flight speed. And liftoff. Liftoff of Tim Koper, Yuri Malenchenko, and Timothy Peake on their way to the International Space Station.
Thank you. So I'm sure a lot of you are really familiar with that launch, and while Tim was on his way to the International Space Station, this is what I was up to. So I spent 14 months in Antarctica working for the European Space Agency, and I'm really pleased to have the opportunity to come to Wired Live today to share that experience with you. So I'm Beth, I'm a UK-trained medical doctor, and I've got experience of working as part of sort of medical and logistical support teams in a number of extreme and remote environments, and these include Greenland, Svalbard, Siberia, and the North Pole. And I guess my journey really started when I was working out in northeast Greenland, and I came across this map, and this is actually the map that I found. And if you look up into the top, And so I love maps, you know, they can tell us so much about an area that we're in. But it wasn't so much what this map did tell me that was important, but rather what it didn't. So if you look up into the top right-hand corner of this map, you'll see that there's nothing there, it's completely blank, except for one word: unexplored. And it was this map that really made me realize what it is about exploration, and in fact, research in general, that really excites me. It's the idea of sort of exploring the unknown and about finding out something new. And for me, space really is that sort of white area left on that map. You know, it really is the place that we truly have left still to explore. And for me, that's why space exploration and space research is really quite so exciting. So this is the global exploration roadmap, and it's been put together by all of the major space sort of players. So you can see Roscosmos, which are the Russians, NASA, the Europeans, ESA, as well as many others represented by this. And what you can see is that the main aim for all of these agencies is essentially towards sort of longer duration missions and ultimately to reach Mars. Now, it has been projected that we might get there as early as sort of 2022 or 2030. And while personally I think that's a little bit optimistic, I do truly believe that I will see humankind step foot on Mars within my lifetime. And we're already starting that mission, so we've seen sort of robotics and unmanned missions already paving the way. You know, we've already reached Mars with robotics. And over the next few years, the International Space Station is going to be decommissioned, and the sort of lunar moon village really is sort of the next step, as well as the development of a deep space gateway and a lunar orbiter. So this really is what's happening at the moment. But it's not just that we're looking at. We're also looking at the human aspect as well, and that's really where I've been involved and what I've been up to. So you might be familiar that these two astronauts recently spent 12 months aboard the International Space Station. And this was a really exciting opportunity for us to really explore the effects of long-term sort of space missions on the human body. But we're not just using space. We're also using a number of ground-based terrestrial analogs as well. And these are sort of a variety of different places, and what I mean by a spaceflight analog is just essentially any environment which in some way replicates space. So we have lots of different ones. We use them either for astronaut training or for research purposes. So you might be aware of NEMO, which is an underwater project which happens in Florida, and this is really looking to investigate the effects of weightlessness and for astronaut training. There's also another one, Mars 500, and this was a crew of 6 people selected as you would astronauts who spent 520 days in essentially a mock-up spaceship in a Russian car park. So lots of different studies going on there. But this was really great because we had a lot of control from mission control. We were able to sort of simulate emergencies and do lots of things that we're not able to in more extreme environments. This one might be pretty popular to a few of you here today. And this one's looking at the effects of sort of weightlessness again and the degeneration that that has on the human body in terms of muscle and bone health. And then there's Concordia. So this is the base that I was stationed on with the European Space Agency, and this is out in Antarctica. And it's one of only 3 of the inland stations in Antarctica. It's about 1,200 kilometers from the coast. And the reason that we're interested in that we use Concordia is because the crew there are completely isolated for 9 months of the year. And the reason for this is twofold. And this is during the overwinter period. So this is a screenshot that I took while I was at Concordia in the middle of the winter. And I guess the first thing you might notice is that it's pretty chilly, so -80. It's the kind of chilly where if you get like the fire hose and put it out the door and spray water out, it will all freeze before it hits the ground. Or if you throw a cup of tea, it's kind of that kind of cold, you know. And also you might notice as well that the barometric pressure is pretty low as well, and that's because we're actually at altitude, so it's a bit like living at the top of Mont Blanc for the year. And the other thing is we go for 105 days where you don't see the sun at all. And this is a picture. I'm actually that little dot that you can see at the bottom of the station there. You can kind of just about make it out. And this was actually taken around lunchtime. So it kind of really does look like this during the long polar night. And so it's these 2 factors together that means that the crew are sort of isolated, even in case of emergency, for those 9 months. And that's what makes Concordia a really interesting platform for us to do our research on. Now, if we compare this to the International Space Station, if an astronaut is currently to have a medical problem, we can normally evacuate them within about half a day. But obviously, if we're looking at going further into space, that's no longer going to be possible, which is why we're having to use platforms like Concordia in order to sort of discover and develop the medical models, as well as sort of research the psychological pressures that those crews are going to face. And if we compare it to other analog programs, so for example, the Miles 500 crew, having spent 14 months in Antarctica at Concordia Station, I personally think I would have found an analog program like this much more difficult to be involved in, because I would have probably spent sort of 499 of the 500 days wondering whether I've made the right decision or whether I should leave the project, because it's kind of an artificial isolation. That's not something that you really consider at Concordia, and so in that respect it's a lot easier. But whether it's harder or easier in many ways is pretty much irrelevant, because the important thing is it puts a different psychological pressure on the crew. And that's really what we're able to study at an analog like Concordia. And there's a few other things which make it interesting as well, so sort of similar to spaceflight. So this was my overwinter crew. It's a small international crew, much like we see on the International Space Station with lots of different language barriers. We also have what we call human behavior performance training before we go, which we have at the European Astronaut Centre. And this is the same training that astronauts have before they go up into space. And it's all about how to sort of live and work effectively together as part of a crew. And because of the really cold temperatures outside, we're also very confined to the base as well. And so lots of people ask me, do you get really lonely going to Antarctica? And it's kind of the opposite. You can't really get away from anyone. And also there's a sensory deprivation as well. So I didn't see any open stretches of water. I didn't see any old people. I didn't see any young people. And I certainly didn't see any fresh fruit and vegetables for the 9 months during the overwinter period as well. And no real smells as well. It's kind of a very dry environment. And we're also developing lots of sort of life support systems as well. So we actually had water recycling down at Concordia, and this is our water recycling machine. The notable difference of the one at Concordia and the one that they use in space is the fact that we don't actually recycle urine. So my top tip to anybody thinking of Antarctic sort of overwintering at Concordia would be don't pee in the shower, because you get a pretty nasty surprise the next day. And also, it's also telemedicine as well. So as I said, we're developing sort of medical models that we're going to need as we're going further away from civilization, essentially. And that's the hospital in Concordia. So all these things make Concordia a really interesting platform, and I'd encourage you as well, if you have any ideas for I've met lots of psychologists and tech developers here at Wired. You know, it is an open platform in terms that you can make proposals to ESA to really test your products and test in terms of psychological experimental protocols that you might have there. So it's definitely worth considering getting in touch with them if you have any good ideas. And on that note as well, I also just wanted to mention this new initiative which has come through ESA, which is called the Ice Cubes project. So you can actually buy one of these cubes, or well, you don't buy it, but you buy the space of the cube, and you can send your experiment up onto the International Space Station. So this is a new commercialization opportunity if you have any interesting research projects that you'd like to do in space. So I don't have time to go into great deal of detail about all the experiments we're doing, but I just want to give you a bit of an overview, a bit of an insight into the sort of things that we're doing down there. So this is one of the experiments we're doing, and we're essentially wearing activity watches. So it's a little bit like a Fitbit. It tells you about your sleep-wake cycle, and it also tells you about interactions. So my watch would interact with another crew member's watch, and it would also locate us on the base as well. So it gave us really interesting insights about crew dynamics and how they were changing over time, and also really trying to work out whether somebody was starting to isolate themselves by spending long periods of time in their bedroom on their own, or are they seeking out social interaction. I'm really looking for critical time points in the mission where this might be more or less likely to happen. Also, as part of the same experiment, we're doing this cognition battery, looking at lots of different areas, so memory testing, reaction times. And while I've included this one because I quite like it, because it demonstrates that while we were doing this experiment down in space, down in Antarctica, astronauts were also doing the same protocol up in space. And this really just shows how analog programs like Concordia are also really useful for increasing subject numbers, that if we didn't have these kind of platforms, we'd have to just rely on astronauts alone to develop, which would obviously take a lot longer to develop the same technology. But why go? I mean, why is it important for us to go to Mars? So Elon Musk recently described Mars as a fixer-upper of a planet, and I'm inclined to agree. I mean, having spent 14 months on one of the closest environments on Earth to Mars, with the added bonus of more oxygen and gravity, I really did feel that I was starting to push my own limits at the end of the 14 months. So if I was to have to consider a one-way ticket anywhere, I think it would have to be much more like this than like this. You know, even if Matt Damon was there. So for me, a mission to Mars is about getting there and coming home. It's not so much about a get-out-of-jail-free card for not looking after our own planet. But it's not just about bringing the astronauts home, but also the technology and things that we're developing along the journey home as well, and back to Earth. And we only have to look as far as Concordia to see how this is possible. So while all of our experiments were directed towards space, they also have a lot of clinical applications for life back on Earth as well. So this is another experiment that we were doing, and it was looking at the effects of artificial lighting on our eyesight. And while, of course, this is really interesting to astronauts and perhaps the fairly small group of Antarctic overwinterers, it's also really relevant to anybody spending long periods of time in areas with artificial lighting as well, so for example, factory workers. And also the telemedicine as well is another really interesting, exciting area, because as the Space Agency's requirement is going towards more sophisticated remote medical care, this means that the research and development that we're doing within the space industry is also becoming increasingly relevant for developing healthcare systems as well, and remote communities. So a really exciting time to be involved in the space research. And here we can see, so this is the same water recycling machine that we had down in Antarctica, actually out providing fresh water for a village in Morocco as well. So all the life support systems as well are pretty exciting, especially in post-natural disasters. And this is another experiment that we're doing down at Concordia, and this is actually the Soyuz spaceflight simulator. And we're using this one to optimize training schedules over time. And really, we're doing lots of sort of human performance experiments, which again have lots of clinical applications in all sorts of different domains. So overall, I'm really excited to see what the future holds and all the new development of technology, because I really do feel that our mission to Mars is the driving force behind a lot of research and technological innovation. You know, when Buzz stepped foot on the moon, we didn't have CT scanners, we didn't have the internet, and we didn't have many of the tools and technology that we rely on every day. So I really am excited to see what new developments we might make by taking the next step to Mars. Thank you very much.